Problem number 4. Solution for this problem you can find in a reference below this video in the description. Two teams of movers are lowering a piano from the window of a 10-floor apartment building. The rope breaks when the piano is 30 meters above the ground. The movers on the ground, alerted by the shouts of the movers above, first notice the piano when it is 14 meters above the ground. How long do they have to get out of the way before the piano hits the ground? Solution. Here we can use a regular formula which connecting height and time for accelerating motion. So if we have height, we can count what is time. Now we can count time difference between whole 30 meters away and the other point which is 14 meters above the ground. So that will be these calculations. So we have delta t equal t2 minus t1, which is this expression for height 30 meters minus this expression for height 16 meters. And the final result is 0.66, which is answer A. Problem number 5. Solution for this problem you can find on the reference below this video in the description. Two projectiles are launched from a 35-meter ledge as shown in the diagram. One is launched from a 37-degree angle above the horizontal, and the other is launched from 37 degrees below the horizontal. Both of the launches are given the same initial speed of v0 equal 50 meters per second. The difference in the times of flight for these two projectiles, t1 minus t2, is closest to what? Solution. Of course, here we can use regular equations to find what is total time. In that case, we have to solve a quadratic equation for this trajectory, but here this shortcut. If you see in this projectile 1 trajectory we have 37 degrees above horizontal, but when this projectile reach the same height 35 meters, that will go same 37 degrees but below horizontal with the same speed as for this projectile. So it means that projectile 2 and projectile 1 have the same conditions for motion from the same height, and they will spend the same time for that. It means that total time difference will be just motion from this point to this point. And now we can easily to count what is total time using this formula. This is just equal speed difference in a vertical direction, which is 2v0 sine theta divided by g, and total result is 5.6, around 5.6. That's between 5 and 6, but it's closer to C, so probably that's correct answer. Problem number 6. Solution for this problem you can find in the reference below this video in the description. So problem. A projectile is launched across flat ground at an angle theta to the horizontal and travels in the absence of air resistance. it rises to maximum height h and length a horizontal distance r away. What is the ratio h over r? Solution. Here we can find what is the distance using this formula. Distance equal Vx multiplied by total time t, which is V0 cosine theta t. Now how to count time t? That's the formula. So total time to travel is a change of vertical part of velocity to Vy over acceleration g, which is 2V0 sine theta over g. Now we can substantiate this time t in this formula, and total range d will be this expression. Now we need to find what is total height. Using a well-known formula, total height equal v vertical square over 2g, which is v0 square sine square theta over 2g. And now to find what is a ratio, we need to divide h over d, which is this expression, 1/4 from tangent theta. Correct answer is E.